In this session of Ccna series, I will do a lab on Ospf default route and load balancing method. As you know, we can also use Ospf to advertise static routes onto your network. Here we have a scenario where I have an enterprise network consisting of R1, R3, R5, R2 and a PC. And this network is connected to internet for end user internet access. This can be achieved by using a routing protocol such as Ospf to advertise a default route within an enterprise network for internet connectivity. So the R1 which is connected to ISP has a default route to internet. Default route to R4 which is acting as a ISP router which is connected to internet. So we have a default route pointing to R1. So for subnet within the enterprise network, a default route is needed. So the router which is connected to ISP router has to advertise the default route to other routers using Ospf. And this can be possible by enabling one command on R1. So first let me hop onto the router R1 and show you we have a default route to R4, that is our ISP router. Okay, so let me show you, show IP route. Here I have a default route pointing to R4. So this router can reach internet actually. Let me ping DNS server. Here you can see I can ping the DNS server, but the routers inside cannot reach the internet. Let me take the PC and try to ping. As you can see, it says destination host unreachable. Okay, so it is because there is no default route on this router R2. If you see here, there is a no default route to the router R1. So let me enable the default route generation command. In Ospf, you can enable this under the router Ospf subcommand. And the command is default information originate. So this command will advertise a default route to the other routers. Let me go ahead and enable it. Now if I check on router R2, you will see a default route. As you can see, an external route being advertised via 172.16.2.1, which is our next hop router. This is the router R5 advertising it to R2, and R5 is receiving it from R1. If I hop on to the router R5 and do a show IP route, you will see here the route is being advertised from R1. So let's go ahead and try to ping the DNS server, and you can see I can ping the DNS server. That's because I am receiving my next hop, that is R2 is receiving the default route from R1. So with this, there is another interesting thing which you should know. The Ospf subcommand default information originate tells Ospf on R1 to advertise a default route when its own default route is working, and to advertise a default route as down when its own default route fails. For example, if I remove the default route on R1, check the command. Okay, so I will remove this default route and then this command will not work. Okay, when the default route is not available, this should not work. As you can see, the default route has gone. So whenever the default route is not available, the default information originate command will not work. So there is another command which advertises the default route even though if the default route is not there on R1, and that command is on R1. If you enable under the OSPF command, if you enable it using default information originate, no matter if the default route is available or not, it will advertise the default route. And for sure the communication will not work, but uh, the default route will be available. So let me bring back the default route. So our route will be available. Similarly, will not be any change in the route. So the default route will be available if the default route is not there on R1, or if it is there, this route will always be there if you have default information originate always enabled on the gateway router. Another feature which I want to discuss is OSPF load balancing. Okay, so if you have multiple paths to your gateway, and if you like to have multiple paths available in your routing table, or if you have multiple paths to reach a particular destination, OSPF supports load balancing and can share the load on multiple paths. The router can put multiple equal cost routes in the routing table based on the setting of the maximum paths number router subcommand, and by default the number is 4. So by default the OSPF allows the installation of up to 4 multiple paths of a single network with identical metrics. That is important, and this number may be increased to a maximum of 16. So a router can load balance the packet on either a per packet basis, per destination basis, or per ports, UDP or TCP ports. So note the per packet load balancing is generally a poor choice always, because it causes the most overhead work on the router. So the default method, that is the load balancing based on destination IP or source IP, is a better option always. So for example, if I have a default route pointing to the ISP, I should have multiple routes on R2 pointing to R3 and R4. Let's hop on and do the same. Let me go on to the router R3 and see if I have the interfaces enabled. But before that, let me show you. I will have a single route to our ISP router or a default route, and we have another loopback which is configured on R1 being advertised to R2 via R3 and R5. So let me go ahead and enable the links on R3. And the OSPF neighborship should be up. Okay, once the OSPF neighborship is up, I will have a multiple paths on R2. As you can see, now the default route is being advertised via both the uplinks on R2. 2.1 and 3.3. You can see here 2.1 is R5, 3.3 is R3. So I have a default route towards both the interfaces, and similarly the R1 loopback is also being advertised via both the interfaces. Let me show you. We can have so to enable the maximum, by default it is always 4. If you want to have more, you can configure it via this command, maximum path 1 to 16. So you can have 5, for example, if you have 5 multiple paths. And I guess that's it for this session. I hope this was informative for you. Thank you for watching.